Hey everybody, let's get going. Steve said he'd probably only be able to join quite late in the meeting. Any updates from anybody who's tried any new submissions?
I haven't submitted anything, but I've sort of got something running with Optuna. I can sort of share with you what I have done.
Sure, go ahead.
Yeah, so as I mentioned last time, what I've been trying to do is to take this baseline from Wanakama and just changing it bit by bit to include Optuna. And I've been doing that following this particular example, which is specifically an example that uses both Optuna and WantDB at the same time. And I think this the author of this example is like one of the authors of the paper for Optuna. And yeah, so like I guess like you've sort of seen how Optuna is used in that NLP course that you've been taking. So basically, very quickly, like to use it, you would create an Optuna study, and you would specify like yeah, anyway, you create a study, and then you would call the optimize method to optimize some objective. And objective, I think it's always like just a function that's got a signature like objective trial. And so and so this function needs to return like I think a single number. That's like a metric you're going for. Yeah, so I think these are some of the requirements. And sort of like the objective function takes a trial, like an Optuna trial. And the trial is basically like you can think of like a single, normally you think of it as a single training run. And so like an Optuna trial, like you can, what you do is it allows you to, so each trial will basically have a combination of hyperparameters, the parameters that you would like Optuna to tune. So like it provides like methods like sort of, for example, here, there's a method called suggest categorical. So like, so calling this method allows you to choose like a value to assign to a name, like a value from a list of possible values. So here, like it's quite evident, like what it's trying to do here is for this particular training run, you would like Optuna to choose one of Adam W, MS prop, or SGD as your optimizer. And so there's similarly a method for choosing a float number from a range. And so you use suggest floats. And yeah, so like when you use these methods, basically the first argument is always like a string, a name for the variable that which you choose. And then the next arguments are they specify the the possible values that this particular variable will have. So here, like the learning rate can be chosen like from anywhere between like 10 to the minus 5 to 10 to the minus 1, and so on. So you have like such as categorical for choosing like a single value from a list, so just float for choosing a float number from some range. And yeah, there are also other similar methods like suggest int for choosing an integer from some range. And yeah, so basically, this is how you ask Optuna to choose as the value for parameters for you. And then once you've done that for your run, like so before you start the training, you want to create a want.db instance. And so, like, to be honest, like for most of it, like a want.db is kind of separate from Optuna. But so in this example, like you would create like a want.db instance before you start training over the epochs. And then once you sort of start training.
Jack, a quick question. Back in setting Optuna parameters, how do you, if for example, let's say one of the optimizers, let's say Adam or RMS prop, require a parameter that is not required in one of the others, how do you control that in a trial or whatever? Do you just provide another value for that and that value will be ignored for the others, or how does that work? You know what I'm asking, like if suppose there is a parameter, not just a learning rate, but suppose there is an alpha parameter, I'm making up, but just to know how to handle that situation. If you have, let's say, alpha, and alpha has to be set up for RMS prop, but there is no alpha in Adam W. Can you handle that this way, or do you need to do something special?
Yeah, so I mean, yeah, it's a good point. I mean, so this is a simplified example, so I think it's probably better to jump straight into sort of what I have done, like after changing Nakama's notebook. So in his notebook, he uses this function to create let's see. He uses I know what you mean. Like in his example, he's fixing the optimizer class. Yeah. The only way. So I guess like I mean, one of the easiest ways to deal with this is to kind of write your own like conditional statements, right? So like if the optimizer class chosen by Optuna is Adam W, then you use this signature, right? If it's RMS prop, you will use like a maybe slightly different signature. And each optimizer's class's signature would require you to provide the appropriate hyperparameters.
I see. So
you know what I mean? Like,
in general, Optuna would work for kind of the generic cases, and then anything unique, specific, you would have to do that internal to what you're executing then.
Yeah. So Optuna is actually quite simple. It doesn't do those things for you. You have to do them yourself. So like in this case, in Nakama's in his configure class, he actually has parameters associated with add and W, right? But if you want to use, say, just SGD, which doesn't require these, then like if you just call, if you have some conditional statements here, then you're just calling SGD. You just don't include these extra hyperparameters, right? You just include these two.
Or so within, for example, your run, you would say if because Optuna is choosing add and W, so you could come here and say if add and W, then set these parameters, else set some other parameters or whatever within your code. So that's how you might be able to handle it, right?
Yeah.
Or that's one way you could handle it.
You could just put those statements here, right? Or you can sort of put it into another function and refactor into another function. Okay. So I guess like so if you remember, like so basically the way that so if you remember, like you need to define this objective function with this quite particular signature or syntax. But if you look at, obviously, the original notebook doesn't have this. And so, but the closest function in the original notebook is this function called training loop, which does the training for some particular fold of your data. And so at the beginning of this function, you create these data loaders, you prepare your data, and then you define your neural network. And then you would define your optimizer, and your scheduler, your loss and criterion, and then you start training. And so what I did was by comparing this code here with the example, like I guess the natural thing to do is to kind of start so I would create like the objective function and then start the function like from roughly this point onwards. And what I did was like I first removed some of the, well, to make things simple for me, I kind of, because when Akama here is actually doing training as well as he's also like recording the predictions on the validation split, and then sort of keeping a record of it so that he can train over all the folds and then do like a like a cross validation, right? Like auto fold predictions. And so I kind of removed some of these final bits, and it's probably simpler just to show you here. So here's the modified train loop function. It has the original signature, and then you also just prepare the data as before, but now sort of wrapped around the original training loop over epochs. Now I have a nested objective function. So here basically inside the function, I now create a model because I want Optuna to maybe like select different parameters for my model. So model creation should be included inside this objective function, right? And the same thing goes for the optimizer. I might want to select different learning rates or word decay values. I mean, I want Optuna to do that for me, so I also include it inside the objective. And yeah, and also like the criterion, which probably doesn't need to be included in this objective. Yeah, so this probably can actually be moved outside. And then, yeah, and so once Optuna has chosen specific combination for the model, the optimizer, I create one DB instance for this particular trial, and then I start training. So, so the training, basically you train over over multiple epochs, and so for each epoch, basically you call a train function which processes the training data loader, and then after you've trained for the entire epoch, you validate for the validation split. So you call like a validation function, and then once you've so the validation function, the way Nakama defined it was like it returns the predictions on the validation split. So using these predictions combined with the ground truth, you can just feed them to the metric function, and then you will get a competition matrix score for the validation split. And actually, this validation score is the score that the Optuna's objective function expects you to return at the very end, so that you can tune the hyperparameters. So,
by the way, one question / comment, or how come you didn't include number of epochs as one of the Optuna things to optimize? Isn't that something?
Actually, I have. I will show you like later. Yeah, actually, I have asked Optuna to select the number of epochs to train for me. Yeah, you will see it later.
Okay.
Yeah, okay. So right. So as I was saying, like from Nakama's original code, you can take the return score, the competition matrix score on the validation set, and then ask the defined objective function to return it. And so basically now you have completed the definition of an objective function that Optuna needs. And one of the things, so you may ask, like, how does Optuna does the tuning? So once it selects some hyperparameter values during training, like here, remember, like we're focusing on the score. If at some particular epoch, well, at every single epoch, you would report the validation score to Optuna via the trials report method. So you would give this method to the epoch. You tell it like which epoch you're on at the moment, and you tell it like what the validation score is at in this epoch. And once you've reported that, you can call the should prune method. And I think when you call this method, like it returns true if Optuna doesn't think this is a promising run, and false if Optuna thinks it's a promising run and it should continue to the next epoch. If it doesn't think it's a promising run, it will just basically you would raise this exception, and then Optuna will just terminate this particular trial and then move on to the next one. And when using 1DB, what you do is you need to remember to sort of record in your run summary that, oh, this particular run was actually pruned, to indicate that it was stopped prematurely by Optuna. And then you also need to finish properly. If Optuna doesn't sort of terminate this particular trial prematurely, after training like all the epochs, you still need to call 1DB finish to sort of finish the 1DB run properly. And then of course you can record on your run summary that it's a completed run as opposed to a pruned run. Right, so that's the objective function. And once you've defined it, you just create a study. And then in this case, because we want the score to be as low as possible, we set a direction to minimize. And the study name, like you can choose whatever name it is. And the pruner, like I think this is like, so I guess this is like the heart of tuna, and there are various different pruners. Because I haven't read the paper, so I don't know like what pruners they are, and like if there are more advanced pruners than the one selected here. But anyway, once you've created the study, you call optimize, and then you give it the objective function you defined above, and then you can set the number of trials, the number of different combinations of hyperparameters you want to try, and a time limit. Right, so once you've defined all this, you've modified this train loop function. You can still just call it as before, but now instead of just having a single training run for some particular fold, you would have multiple runs, and each run is an Optuna trial, basically. So going back to sort of how to change the hyperparameters that are saved in config. So the way I did it was like I kind of just I changed the class CFG to have an additional class method. It's called, so it takes the class and it takes an Optuna trial. And so like when you call it this class method, it would just kind of use those trial methods that I mentioned before to internally change the class attributes, right? So that's kind of how I changed Nakama's code to. So basically, before, like, everything is sort of like a constant inside this CFG class, and now now, yeah, see here now, the very first line of the objective function, I kind of call this class method of the CFG class, so that it changes the values saved inside it internally. So now the CFG class has values that are selected by Optuna before the model is defined, before the optimizer is defined, and so on. And yeah, so these are kind of all the changes that I have made so far.
I see. Can you go back to the parameters that you're changing, the class method?
Yeah.
So you change the scheduler, the warm-up steps, the epochs, the learning rate of the encoder, decoder, and the gradient accumulation steps.
Yeah, so
right?
I guess there's kind of no logic behind why I have selected this. I've just been testing sort of like what happens when I try to include these parameters in my trials. Obviously, you can include more from the list above here, right? And no, like one of the things I included here is the number of epochs to train. So yeah, I'm doing like from 4 to 8. I mean, I could set it lower, right, to 2 to 8. And to be honest, I think I think you still need to be sort of be careful like how you select these ranges, right? You don't want to sort of waste. You don't want to be looking at wrong subspaces. No? But yeah, I guess
right.
here is yeah.
And sorry, one question that this raises is you mentioned the pruning, right? Now, when does Optuna prune? You mentioned, like, if it prunes, you want to remove it from 1 dB, but under what conditions does Optuna prune? When you had that pruning?
I don't know. That's yeah, I don't know, like I guess it's some sort of early stopping mechanism, right? But I guess it's something that's much more sophisticated than that, right? Otherwise,
okay, but it sets some flag that you use in order to make sure 1 dB is aware of it. That's all the pruning does, basically, in the pruning part of the code that you showed. Is my understanding right?
So the pruning is done by Optuna actually, and it's actually completely separate from WAND DB. 1 dB is sort of just used for keeping track of things, logging and visualizing.
Right. So what I'm saying is the pruning information, the fact that Optuna has pruned some run, all that your pruning code does is to transmit that information from Optuna to 1DB. That's it, correct?
That information, let's see, I don't think it's even transmitted. So look, here's the thing, right? Like when you're training and you're logging, you can use one kind of login to two or three types of login tools. In this case, when Akama, the logger here is actually from the logging module, I think. And so he's logging it using this, as well as logging using 1DB. So he's logging like everywhere. So I guess it's just keeping multiple records or logs, I guess. I mean, I can simply delete these lines and the code will still work. And,
right. But what I'm saying is below that, when you say if trial dot should prune, then 1DB run summary state is pruned. So by that, aren't you transmitting that piece of code seems to transmit the information that the trial is pruned to 1DB by setting 1DB's run summary state to pruned, right?
Yeah, but
so
like
that 1DB now knows that that's a pruned run.
But the thing is, if you look at this, you're just manually telling 1DB, you're manually assigning the pruned string to 1DB.run.summary state. And
right.
it's just for record keeping. 1DB doesn't do anything extra when it receives pruned. This is just for your own record keeping, right?
Right. But when you look at 1DB charts and stuff, you can kind of maybe not pay attention to the details in that chart because it's a pruned run, right? I mean, 1DB may not do anything in whether it displays it or not, but if the display of that information is weird or, is not complete or whatever, the fact that it is pruned is also captured, and therefore you need not look at those charts, or at least if you're looking at it and going, why is this chart weird, you would not pay attention to it because you will realize that, oh, this is a pruned run.
Yeah, and to be honest, like I don't know where to look for that pruned string in the web interface. I guess it's logged here somewhere.
I see.
But I think like the important thing is that you call 1DB finish when it's pruned, so that so that when it starts the next trial, when you call 1DB init, you won't get some strange behaviors or errors because you've made sure that the previous 1DB session had been finished properly. Basically, you want to finish a one, So it's more important.
Basically, that's what I meant by transmitting that information. Even if you are not using it, it ensures that 1DB is, let's say, closed properly before it's initialized again.
I guess there must be somewhere where you can check you can check like whether this trial was one that was pruned or not. But yeah, I haven't found it yet.
Okay.
Yeah. So
I'm not a 1DB user yet. One of the things I need to get to someday, but I haven't yet started using it.
Yeah, so using the notebook I've just shown you, this is what you see inside 1DB, which is, I guess, like nested under this, nested here are all the different trials of a study. And yeah, you can see from the spread here that Optuna is selecting different learning rates, for different trials. And so there's some spread in the training loss, in the average validation loss, and the score. And yeah, so this is kind of what it looks like. So you can see here, like, because I had chosen some warm-up steps between 0 and 100. You can see that there are some warm-ups here. And yeah, I guess this is, so if we just look at the score, like the competition score, which is the most important thing, right? And so if you look at the beginning of the training, like you can see like this lower bound. So these are actually the range, like not just variance, it's like the actual range. And this, for this particular trial, the score was already very good at the very beginning of the training. And obviously, it's sort of what I found slightly disappointing is like if you look at the end here, it's sort of like it kind of shows like no matter what trials you do, they all kind of converge on like a similar score. And I was hoping like there would be like some sort of range in the end here, like sort of proving that, oh yes, like using Optuna, you do get the range of final scores, right? That means it's some of the trials work better and some don't. But it could also be that because the total number of epochs trained can be different, that actually here you just get a single trial that's been trained for this long. Maybe some other trials have sort of ended here or here. And yeah.
Well, it depends on the nature of the problem too, right? Like by that, what I mean is the parameters chosen and the problem at hand. Because, for example, in the textbook or in the book that on NLP transformers, they use it to determine the temperature when they're doing distillation. And there, where you really genuinely do not know what parameter to set, it tells you, oh, a parameter of about 2 for temperature, and you could pick anything from 1 to 1,000, and you wouldn't know what value would be good. And it says, oh, something like 2 is good enough, and you can just pick that and go. So similarly, in this case, since the focus in a way is to get you the parameters, and some of the parameters, in this instance, what this chart seems to suggest is your range of parameters chosen is already pretty good. But even then you can see that, it still gives you range as you go, and it's only in the range about 2K runs or whatever that, by that time you've probably chosen the mostly good parameters. So the parameters that you've chosen, those 5 or 6 that you indicated, the values have converged to where, or the values have converged to the close to the best values, to where to the right of 2K, there's not much of an impact of anything. But
right.
In general, since your goal would be to choose a number of things and set their values that you don't have a clue about of what is best, and typically, the epochs, the LR, things like that are in general within a particular range anyway, right? Like you don't expect epochs to be 5,000 or something with these models, and you don't expect the learning rate. That's why you can kind of guess at where approximately those things will land,
Right.
is what I'm trying to say.
Yeah. So like going back to this particular run, this lower bound, right? I mean, out of all the logged scores, like this point is the best, right? And it actually happened quite early in the training run, right? Because it's sort of close to the left. And doesn't this kind of suggest that really like the best score you would expect after Optuna has explored a little bit to be kind of like closer to this value and not something that's higher? So I mean, wouldn't you expect like this value to reappear somewhere like to the right here?
Depends, right? I would think that is totally an accident, right, of the initial choices it makes. There's no reason when you're choosing random parameters that your random value that you start with couldn't be the best, and it has to be some value that you necessarily find after a bunch of trials, because at the end of the day, the values are, if it is chosen within a range, there is no reason that you couldn't accidentally choose, because it is random, you couldn't have accidentally chosen the best values closer to the start of your exploration than at the end. Yeah. Eventually, all it would mean is the end will get you back to where you started or close to where the best was, if Optuna's algorithms are good. But it doesn't mean that you would necessarily find it only at, you would find it at the end if some parameter choices are so way off that you need them to be put. But there's no inherent reason in any randomness choices that you wouldn't hit the right combination early on versus later.
Right. So like if you've done like say a large number of trials, say like 1,000 trials, and the graph still looks very similar to something like this, that kind of suggests, right, you don't need to train for that long, right? It's probably okay to train this much, right? So,
and it's not so much even the number of training as much as the values that you train with, right? Because that's the goal of Optuna, is to say, okay, which of these values gets me the best results? In this case, because your scoring function is the same as the result function, then you're saying, okay, right? But there is no reason that, is it always the case? I'm trying to think about what they were using. Yeah, even in that instance, I'm trying to compare the through memory what they were doing in the other case of use of Optuna. So what I'd be interested in, I haven't used Optuna much other than in that one example, but what I'd be interested in is probably looking at, does Optuna scoring function, is it always the optimization function of your, is it always the loss function? Because that's what you're optimizing in your run. And in this case, that's also the score. And if that is the case, even in the other example. So I'm just curious whether it is always the case that you choose for the scoring of Optuna the function that you're optimizing as well, because that's a single return value function anyway.
Yeah, I guess it makes sense to choose to choose Optuna score the same as your competition metric, right? Because that's what you care about.
Yeah.
Ultimately.
Yeah, which is what I'm saying. It was, even in the case of not a competition, but just the optimization in the other example from the book, they also choose the function that you're optimizing, which is the loss function. And the loss function invariably is a single number that gives you whether or not you're getting the best results. Right.
Yeah. Okay.
So they're choosing that. So, I mean, the reason I was thinking about that is what you said about, the number of runs versus, because eventually what you're after is with Optuna at least, is the value of the parameters that gets you the best results.
Yeah.
Right? Because it's meaning, yes, it's duration of run because you've thrown in epoch in there, but at the same time, what it says is, what should the values of those parameters be, and then how many epochs approximately you should run.
Yeah. Yeah, I think like even using Optuna, you still have to be kind of clever about which parameters you want to tune and like what range over what ranges, because
right.
Because like so if you look at here, some of these runs, I guess because the epochs is different in each trial, you get different runtime. But like for each Kaggle session, you only get like a max 9 to 10 hours. So let's just say like a trial is like an hour. So I mean, you don't actually get that many trials in a Kaggle session, right? Unless like there's a way to continue like optimizing your study after you've been timed out by Kaggle.
Yeah,
I don't know how to do that.
Yeah, no, that's true. But I'm thinking Optuna itself, if I recall, I may be wrong on this, but I think is from one of these Google guys or whatever. And so for them, they are more, they aren't limited by run length, durations and stuff, right? So they just, I guess, let it.
Rest.
And you could potentially do that on Colab too, like as long as it, so you could run it for a while because the other thing, as I keep repeating, is eventually what you're after with the Optuna run is to find the parameters that you then need to set for your final run, or not final, but your actual run that you care about, right? Because these are just attempts to determine the parameters.
Yeah. So like, actually, that's one of the things I need to do next. I need to figure out like how to retrieve the best trial after Optuna has completed, which I
Yeah,
don't
there
know,
is
I don't know where
the,
it's
in
in.
fact, yeah, in the textbook, they just say that there is this best run, if I recall correctly. You can just quickly go to NLP with Transformers book, chapter 8, and in that,
Okay.
look at, I think I'm talking from memory, but there is something called the best run that you can just extract from Optuna, and it will tell you the parameter values.
Okay. And I guess like you need to repeat that run and then save the model, or like do you, I mean, I guess you can't really save the model for all the trials, right? If you are trying a very large number of trials, you run out of disk space, or I mean, is it normal practice to go back to the best trial and then run it again, this time saving the model? Or like do people normally save the models
Again, I'm talking from
for
memory. Mine can correct me if I'm wrong, but I think in the book they run it with the best parameters, if I'm not mistaken, because they use it, for example, like I said, the temperature value that they want to determine, they determine that the temperature setting should be 2, and then they run it with a temperature setting of 2 and with the number of epochs as whatever, 2 or 3 or whatever the value is, and that's the best run. So they run that again, because that's a quick run of just a single setting of the parameter, of the chosen parameters, if you will, from the best run. At least in the book, that's what they do.
Yeah. You know how like you normally, when you do ensembling, you kind of want to adjust the weights to each member of the ensemble. So
Right.
Optuna, it's very general, right? I mean, you can decide what you want to include inside each trial, right? You can, so here, my trial only encompasses a single model for a single fold. I guess you can throw into a single trial more things, like you can throw in all the folds and then kind of make the weights for your ensembling a parameter inside the trial, right? If you do that, like maybe you just get like a completely ensemble, like after.
In fact, if you recall, Jack, in fact, that was the reason that triggered this whole discussion of Optuna and stuff. In fact, in the prior competition, that's exactly what people had done, which is, I should be careful when I say that, they had used Optuna to tune the weights by which you, or not tune the weights, to identify the best weights for ensembling a model. So I'd be interested, in fact, to see whether any examples of use of Optuna for tuning weights of ensembles exist. But it shouldn't be that hard, because if you have the model, then it's just a matter of setting the weights as one of these parameters that you allow Optuna to vary, and then the score can still be the final score, and then you provide it with pre-trained models, and then you just run the trials to be varying just the weights.
Did they use Optuna to train everything, or like including the hyperparameters of each model as well as the weights in the ensemble?
No, that's not what at least I haven't seen any notebooks which do even the determination of weights, but they talk about using Optuna for that. And I would assume that they do those two things separately, just because of the sheer complexity or the runtime duration of what we are talking about. Because if you're trying to determine all this, like you already said, which is for a single model, that itself takes a long time. And then you have to do it, determine those, if you assume that you want to choose a variety of parameters for each of the model, and then choose the weights by which you combine it, that would, be a combinatorial explosion. So my guess, and I don't know, which is why I'm curious whether their examples exist, I would assume they do it in stages. That is, they use Optuna to tune parameters for within models and do that per model, and then use another Optuna run probably to determine the weights of ensembling, but I could be wrong. I mean, that's why I'm eager to see whether any examples exist in Kaggle or elsewhere.
Yeah, you're probably right. It's probably better to do them in stages. Okay, so I think that's all I have want to share with you guys. If you guys have any suggestions for learning rates ranges, for example, yeah, I don't know like if these are any good, but yeah, anyway.
No, but those are typical values, right? I mean, there are some typical values that for any of these that people talk about. So if you choose some typical values and vary them by an order of magnitude this way or that way, I think that should be, or a couple of orders of magnitude, and you have the log setting. So that's probably in the right range. I don't have an idea about the warm-up steps and stuff. So, and I don't know whether you could, like, just like you, the one thing I have seen in many of these prior competition, FB2 and FB3 as well, the current one, if people have chosen different, different warm-up methods, and that could be a thing that you provide as a string, if that's possible. Just like you were showing different optimizers, you can just stick with one optimizer, AdamW, but then use different warm-ups, because there seem to be different warm-up capabilities that Hugging Face provide. Like I've seen cosine, and then I've seen some linear stuff that people do. So that might be a variant you want to try.
Okay, thanks.
Hi, Steve.
Yeah, sorry, I'm running late today.
That's okay.
Did I miss much?
Join us. Jack gave excellent walkthrough of his code of combining, the basis, the Namaka notebook, along with, he was trying to use that and combine it with 1DB and Optuna.
Right.
So that's, he took us through the walkthrough of what he had attempted to do with that code, and combining that with the Optuna, determination of parameters, and combining that with 1DB as well. So that's what we've been discussing for the last 45 minutes or so.
All right. What about yourself? Did you get anywhere with the AWR or whatever it's called, the cipher?
Yeah, no, I still can't claim I understand. I have to code it myself, but I used that notebook and stuff, and then I used another notebook, two of the notebooks which use basically Diberta large, but different settings, and that I shared previously. And then what I tried to do was ensemble the two of them and see whether that gave me any better results. But I still ended up with the same 0.44 results. So in a sense, it doesn't seem to improve by just ensembling two different models. So, and I tried it with different weights as well. It was running, I submitted it before the meeting started. I'm just checking it right now, and it still gives me the same 0.44 number. So it seems like, and I'm assuming that's also because, I have to go back into the notebooks and check, but it seems like the results are provided with 2 decimal points, and I need to see whether I can increase that, because all the results of mine are like, well, it's the same, you're gotten the same score as before. But from what you told me last week, if I understood correctly, that even though your score is 0.44, you continue to move up the leaderboard. Is that right? Is my understanding correct of what you mentioned last week?
Yeah, I think so. Yeah, so like when you submit your thing, it'll come back and it'll say you've got the same score as last time, but if you've done better, it'll say congratulations or whatever, you've improved your score.
Right. Right.
So if it says that, you've got a better one than your previous submission, but obviously you can't tell by how much.
Correct. Yes. And in my case, both my runs said, "Oh, you're in," and I'm somewhat surprised by it, because, I can see my individual. You have those 6 values, right, and then the table of the 6 numbers for the 6 classes, and I can see the numbers have changed. Not by much, as you would expect when I'm ensembling, but definitely the 2 values that I'm ensembling are slightly different, and therefore the combination is slightly different too. And I continue to be surprised that with, whatever number of entries that are there in the public leaderboard, that despite my ensembling and having 2 different notebooks, I end up with the same exact 4-digit number. Because that's what the results seem to be saying to me, right? Like, because 3 times I have 0.44, and all 3 times it says, well, you have the same result, which is kind of interesting, fascinating, because it says that, either I'm rounding my or chopping off my results, which I have to go check whether I'm doing, or I'm amazingly still in the close enough to where my 4-digit results continue to be exactly the same.
Yeah, I think if it says you've got the same result, it just means you've got 0.44. And if it comes back and it says you haven't sort of improved on your best entry or something, then you're maybe worse. But in terms of like the cross validation score, did you get any improvement in that? Yeah, because I was going to try.
That's a good point.
Yeah, because I am. Like I was just using the notebook like the Jack was using. What's it called? Then the MacKit one, or whatever it is. But yeah, like the notebook that you'd shown. Yeah, so I was going to try sticking the SIFT thing onto that.
So did you do this SVR thing and modulate or try to fine-tune each of the components? Did that help improve your score?
Oh yeah, so like this week, like this notebook, this is the one that you were looking at, isn't it?
Yes.
Yeah, so like within this, he's got a couple of ideas or whatever. One of them, like I started out with, is like a thing about sort of changing the when you got the new line character, encoding that didn't help at all.
Right.
And then I tried, like last week it said there was like a discussion that was sort of mentioned sort of metric values that sort of estimate how good the readability of text is. So like I spent a lot of time. There's like this library called Readability, which you can stick text through it and it comes back and it gives you like a load of scores and sort of tells you like how many sort of consonants and how many big words and small words and stuff are used. So I tried that, and again, it didn't give me any improvement in the slightest. And then I found there's a notebook. This notebook here. Sorry, by this guy. It's really good. It's like an ensembling notebook, but he does the ensembles in a strange way. Like normally, like when I used to ensemble, I would sort of cut and paste the code from each notebook into the ensemble one. Whereas here you can see what he does actually. He loads like the notebook file, and then he just runs it. And as long as you've got like the data sets and things, so you can like really easily sort of ensemble stuff together. And yeah, like with his notebook, this ensemble, I think he's got there's about 5 or 6 like different notebooks in it. So you get like a 0.43 score on that.
Interesting.
And then the other thing I've tried is like, so like this Chris Diot thing.
Right.
Yeah, like I mentioned this one last week. So like what he was doing here, he was bringing in like a load of Deberta models and then just like pulling out the embedding layer without doing any fine tuning. So I've started sticking models in here and fine tuning them. So like put them into this model.
I had a question on that. I had a question on this one. I looked at this notebook. So I had a 2-part question. So first is, if you look at the notebook, he just, my understanding is he still tokenizes the inputs and runs them through this model and gets the embeddings, he calls them the embedding, but it's actually the mean of the output of the last hidden state of these models, right? Because he does use the mean value as I went through the code. So, right, if you look at like after that and blah, 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 further down, yeah, right, not, is it here or is it, whenever he does the models, here he's doing, I mean, he calls them the embedding, but it's the hidden layer. So if you go up maybe or down, I forget now, where is it in the generate embeddings stuff?
Is he not just,
this, he's generating the embeddings. If you go up a little bit further, where does he do the mean? Little further up, mean pooling, right? See there?
Yeah.
So he is actually using the last hidden state of the model. So you run the token, you tokenize, run it through just, he's not fine tuning, I agree with you, but he is taking the tokenization of the text and taking it through the model and taking the last hidden states and mean pooling them using that. He calls that the embedding, right? Is my understanding correct?
Yeah, so like he's taken like like the sort of the last layer of the base of the BERT model.
Correct.
And yeah, like sticking it through this mean pooling thing.
Right. And using that as the feature, because he eventually combines concatenates the 4 or 5 models and creates like this long
that's right.
Feature vector that he then puts through the SV regression.
Yeah, that's right.
Right. So that's my understanding. So now, then my question to you was, now when you say you fine tune, do you basically then just run the model without any cross validation or anything, but just run it for a certain number of epochs on the input data, then do the mean pooling and stuff? What do you actually do when you say fine tune on the data?
Yeah, so like here, he's just pulling like a model straight out of the Hugging Face library and like doing nothing with it. He's just sticking the tokens through it and like getting like the last layer of the base of the BERT model, and as you say, like then sticking it through the pooling thing. But yeah, so like the model here, this DeBerta base that he's using, for example, it hasn't been fine-tuned on this feedback 3 competition data. Whereas what I've done is I've taken the this competition data and the standard sort of notebook. Can't remember which one it was. The Maca one. Is that what you said? So this one here,
right?
The Nakama one. Yeah, so like here I've taken this model, but it's actually been trained on the thing. So like now when you stick the tokens through here and you get like the last embedding layer, because it's been trained on this competition data, its embeddings are like a better representation. And so yeah, so like I've used these within the Christie thing. And so yeah, like, well, I've just added them in with
before he does the ensembling, you could just provide the inputs to his model to be the outputs, or actually you can just do the pre-trained model as the NM that he uses, right? Like you just replace the string with the model that you have trained.
Yeah. So yeah, sorry. So here's mine here. So I've, sorry. Yeah, so like his model, this is like the model from the Nakama thing. But here when you can get, here you've got like the last hidden states on it. So like I return them and then I use these as the embedding layers within the Christie SVR thing. And so like that gives me like a minor improvement. And so like then with that, then I stick them into like this ensembler thing. And yeah, so yeah, like with that, then that gives me a 0.43. So
do you use, have you done it for all 5 models that Deer uses? You fine tune all of those, each of them?
Not yet. And as well, yeah, so like in this one here, yeah, so I've only done it with the Nakama ones, but like within here, as I say, he's got about 5 different ones, like just taken from public notebooks. So like I was intending to do it to each one of them. So yeah, like that's the Nakama one, and then there's like one that uses PyTorch Lightning and a couple of others or whatever. So
yeah. So I tried combining. So
like
in fact, you're kind of, so I use the PyTorch Lightning one and the Lux one, which uses Sift, and I kind of ensembled the 2 of them on my own and then modulated the weights a little bit. And neither of the combinations, neither the ensemble. Now, before we go there, so each of them, the Lux one, my score was 0.45, which is obviously the Lux number as well. So I got the same result he did. Then the base Lightning one is 0.44. And, I ran it myself and I got the same result. Then I said, okay, let me now ensemble the 2 of them, just like, probably the ensemble of Top Solutions notebook. I shouldn't say just because I haven't looked at that notebook yet. Thanks for pointing that out. But so I combined those 2 and my result said, well, you got the exact same score. Thanks. Try with something else. So then I, obviously I just averaged averaged the results the first time. Then I said, okay, let me modulate the weight somewhat. So I increased the weight of the 0.441 a little bit, and obviously relatively lowered the weight of the Lux one because that was 0.44, the other was 0.45. So I reduced the weight of the 0.45, increased the weight of the 0.44, submitted it, and got the exact same result. So I'm like, what the heck is going on? So I'm curious to see Now, it may just be that, within the range of what I'm doing, because I'm obviously combining two things, which are both Liberta V3 large models, both in a very narrow range of 0.4445. So, it may just be that coincidence that I'm just getting the same result by ensembling, but it's kind of, so I want to kind of try something crazy by, dramatically lowering the weight of one, increasing, and seeing, even if my score drops, I'd be interested in seeing that, because right now I'm getting, well, your score is the same for 3 different runs. It's kind of funny.
Yeah. Yeah, so just because of the fact they only have like 2 digits, and yeah, like I saw the discussion about whatever about it, yeah, like they were saying that they don't want people to overfit on the public leaderboard or whatever. That's why they're not going to any more digits. So yeah, I think you sort of do need to do it with your own cross validation to see if you're improving, really.
Yeah, I think that's you're right. I should check my cross validation scores to see what I'm seeing on that. That would be a good. And I was in fact wondering, another thing I was thinking of is combining the Chris Diotte approach with these two and ensembling the 3 of them to see whether any, because the Chris Diotte thing uses a couple of different a base, and I forget if he uses an Liberta XL and MNI or something different than just Liberta V3 large. So I was curious to see whether that made any difference. So I was just going to run the basic Diotte notebook and then try to ensemble it with the other 2 notebooks that I've already ensembled and seen whether that gives me any better results.
Yeah, this guy here, like, that has published the ensemble notebook, he's got like a couple of other interesting ones, like the pseudo label one. I haven't followed it all the way through yet, but yeah, like I was looking at this and like looking at that previous competition that we talked about last week, and like the person that won that just basically won by doing like pseudo labels. So yeah, I was gonna like try and follow like this notebook this week and see if adding pseudo labels and like adding the previous data from the other feedback competitions in to see if that would boost things or whatever. So
yeah, I noticed the pseudo label one and I bookmarked it. I didn't have time to go through it either last week, but on that note, I will share one piece of work that I did was, I think Jack had asked me, which triggered my doing this, was how much is there overlap? And I'll just show you guys something that I did, which I can share my screen. Let's see, which is interesting. They kind of seem to have provided data. I'll give away the punchline. The punchline is there is very little overlap between essays in this bunch and the essays used in previous competitions. I was thinking that it would be a complete subset because the number here is fairly small, right? There are only 3,000. Can you see my notebook?
yeah.
Okay, so I just kind of was comparing the essays among the 3 competitions, right? So, just to give you an indication, the total rows is somewhat confusing because remember that in the prior competitions, essays could repeat. So don't look at that, look at the unique essays, and you can see that feedback 1 has the most. Feedback 2 was a smaller subset, and it turns out that feedback 2 was a proper subset, if I remember my math terms correctly, meaning it was completely, all of the essays from FB2 were in FB1. But it turns out that the FB3 is smaller, so I assumed at a first glance that all of these essays would be in here, but it turns out that's not the case at all. Most of these essays are not in the FP1, nor are they in FP2, which is kind of interesting. So it seems like they released a whole new bunch of essays for this competition. And the reason I say that this is just the total, forget the rows, as I said, just look at the essays. This is the total number of unique essays in each, not as a total. But then I try to do, this is why I say that FP2 is a complete subset of FP1, because when you try to make them a set like I did here, and then you do the subtraction, which is basically intersection, if I recall correctly, then it gives you a 0, which means that all the essays in FP2 are in FP1. But that is, and you do the reverse. That is, you say, okay, how many in FP1 are not in FP2? That's 11, 14, or 3. So that's, you subtract that from 15,594. But see what happens when you do the same thing in FP3 and FP1, you find that 3,459. So which means, and I did the math here, like there's only an overlap of 452 essays between the two. And all the rest, meaning this many, are in FP3, which are not in FP1. And similarly, you can see that if you do FP2, FP3 overlap, there's, I did that somewhere here, and there's like 158 are in common. So just FYI, this was something that gives you an indication of the overlap or lack thereof between the essays in the various groups.
Thanks. So that gives you a lot of pseudo labels potentially. And did the guy find any significant improvements doing pseudo labeling?
Oh, in his notebook there? I'm not sure. I haven't actually looked at his score.
I haven't looked at it either.
But as I say, in that previous, I can't remember what it's called, the Common Lit thing or something, it's like the competition from a year ago. Yeah, like the guy that won it, just basically, that's all he did was pseudo label. He didn't sort of any fancy models or anything. He just used pseudo labeling. So, and I know, like, Christy or whatever, he's in the chat or whatever, he's sort of mentioned it as well. So
actually, in the feedback 2 competition, where I followed and I ended up with a reasonably good score, got a bronze and stuff, was one of the 2 notebooks I ensembled, in fact, of the Lux guy. He used pseudo labeling of all of the essays in, remember, in case of that competition, all the FB2 competition essays were also in FB1. So, right. But he used pseudo labeling on the essays from feedback 1 competition and used them in the feedback 2 competition. And that definitely helped improve the score. So that's just a data point, another data point to back up what Steve is saying. Even in the feedback 2 competition, using pseudo labeling to generate the effectiveness, because we had I forget what the terminology is now. Discourse types were provided in both competition, but the effectiveness scores were not available for the essays in the feedback 1 competition. And by using pseudo labeling from feedback 2 competition on all the essays in feedback 1 competition, you could generate a whole bunch of new data. And when you included that into the feedback 2 competition, back into the feedback 2 competition as data, it improved the results of your feedback 2 competition. I saw that, and I did that myself too.
Yeah, like it definitely looks as if it's a way to get like a bit of a boost in your score anyway.
Yeah. So I would definitely probably this week spend some time looking at what he has done in pseudo labeling. But everybody seems to be, I'm kind of still waiting for the leaderboard guys, somebody to break through. It's kind of like total log jam between 0.45 and 0.43.
Yeah, nobody's beaten 0.43 yet. So
Yeah. And usually, for anything this long, people kind of inch their way upward and kind of keep pushing on it and figure out new ways. But in this case, I'm seeing like a lot of people get to 4.5, 4.4, 4.3, and then just kind of like there's no improvement beyond that. The other thing I was thinking of trying, Steve, to your point, because the idea from Chris Diotte approach seems to be a good one. The other thing I didn't have time to do, but I wanted to try is, I think in one of my prior discussions a couple of weeks back, I'd mentioned all the various ways that from the website, I forget whatever the site that provides this automatic, the best scores and all that kind of stuff. I forget this website name now, but a paper switch code, the automatic essay scoring kind of thing. And then I was going to go and look at any kind of feature generation that they use and see whether I could generate some features using those techniques from any best scoring notebooks there, and then combine that with the Chris Diotte approach by just providing those as tokenized features or even just features to combine into that one long feature vector. Does that make any sense?
yeah, like I think so. Like certainly, as I've put sort of models in there that have been trained on the data and just added more and more stuff, it gets me a slightly better score. So yeah, basically if you can like put any models into like the Chris Diotte notebook that are better than sort of untrained models, I think you should see some improvement.
Yeah. The other thing to think about is that I was thinking about is whether you can change the SVR that he uses with something better that would get you a better score.
Yeah, I'm not sure. I don't really know about SVR, so yeah, like I've just taken his notebook and used it. But yeah, like in the past, like when we did like something like the Ubiquant tabular competition, yeah, like I didn't use SVR there. I was using neural network models on the top, and so yeah, perhaps they would improve things.
Yeah, that's what I was thinking. Because SVR basically is just using the feature vector and then using a regression head on top, so to speak, right?
Yeah.
So I was thinking one is improve the inputs going in, and the second is improve the network that it goes into. But you're right, there's no guarantee that that would improve anything. It might overfit as well and fail to generalize. But I just thought that might be worth a shot too about trying things.
Yeah. So like at the minute in his like original notebook, there was like 5 models that he uses. Like as I say, they're all just 5 straight from Hugging Face, without any fine training. So I've replaced one of them and got like a slight improvement on his score. So I was going to work my way through the other 4 and do the same to them.
Yeah, that should help, I think.
And yeah, like that's why I was wondering about the AWR thing or whatever, if it had helped you get like any improvement in the CV score.
Yeah, on the CV score, yes. Within the runs, when I was just using the notebook that Lux guy had, the Lux notebook, which uses Sift. Now, as he mentions, I also see the same thing. I mean, no surprise, but with Sift, it takes so his notebook takes nearly 8 hours to train.
Yeah.
Because the Sift, I mean, he does this obviously 5 folds, and the each time, if I recall correctly, either the second and the third or just the third epoch is something that he trains with Sift, and that takes a very long time. And as we discussed before, he does, which is an important thing to keep in mind, is he says why he does it on only the last 2 epochs or the last epoch is because you want the model to get to some level of having a model that's good enough, and then subject it to this noise, rather than subject it to noise right from the very beginning, because then you impact the very act of learning the basics, so to speak.
Mm.
But you do see a small improvement in the CV when you run it with Sift and without Sift.
And do you remember that Sift benefits from training for like longer? So if you can break that notebook into, so just training 1 fold per notebook, you can train using Sift for longer. And then, I mean, you can just save the models and still ensemble them afterwards.
Yeah, he uses a few other things too, like I think, I forget now, gradient.
Checkpointing?
Uses other, sorry?
Yeah, gradient checkpointing, you mean?
Yeah. Uses other ways to kind of improve that. And I think the only reason he does, actually he does 4 folds, if I recall correctly, because I think he did not want to run the 5th fold because he is afraid. This was my takeaway, although I should probably ask him in the chat and see whether that's the reason. But he does 4, because by 4 he's at like 7.5 hours or something. And I was like, well, I think he just doesn't want to risk another fold and then have it crash. And so he backed off to 4 folds. But I don't know that makes a whole lot of difference.
Yeah, like as Jack says, you can just do the training by itself a fold at a time and save the models. And then you don't have that amount of time when you do the inference.
Yeah. Good. So a bunch of ideas to try, I think. And we have time in this competition, so that's kind of good as well. And a bunch of different ideas too. But it's kind of interesting that even the experts are all kind of like log jammed right up there with no significant breakthroughs happening. Because periodically in the prior competition, you'd see some, a lot of people stuck at like 0.28, and then suddenly somebody would go to 0.29, and then there'd be a rush of like 4 or 5 people all figuring out, oh, here's something new to try, which will improve. But in this case, that does not seem to be the case, which in itself is fascinating.
Yeah, it's still early days, though, so probably somebody will find a
that's true.
unique feature and
Yeah.
pull away.
Yeah, but it's always, it's also interesting to me that something that people write about in science and innovation and technology, that very seldom is the case that one group or one person finds a breakthrough that does not occur independently to multiple people. And you can see that phenomena, at least I have observed it many times in Kaggle competition that, everybody would be at some level, and then suddenly somebody figures out, not suddenly, but through a lot of effort, but I'm sure from the outside it looks like suddenly one person will jump, and then there will be a clustering of people who are all at that level very quickly. So it's kind of an interesting and fascinating phenomena that apparently takes place in real life as well, that, if somebody thinks, oh, here is a way to broadcast radio waves or figure out a phone or a TV, very seldom is the case that it occurs to one person, because multiple people are all working on the same technology, trying to push it in approximately similar directions, and they all hit on some combination of similar ideas at about the same time, not exactly, but about. So it's always fascinating how that happens.
I think in Kaggle competitions as well, it all tends to be like the first sort of public notebooks that come out sort of doing well. People just head down those routes, and then they're just sort of making minor modifications to something that's out there already. And so everybody, their score goes that way and then stagnates. So
yeah, that's true as well. Yeah, but there are people who do their own thing, and then, but like in the, I forget which one it was, right? Like, was it the not the feedback 2? Which one was it that before the feedback 2 competition? There was another one that on NLP that we did. I forget now what it was. But in that.
Oh yeah, the US
sorry?
patent one. US patents.
Oh, the US patent. Yeah, and that one, right? Like a group had figured out that the encoding mattered and how to encode, and everybody in that group was ahead of the rest of them, the people who had not figured that secret out.
Yeah,
right?
like
And I don't think
sure
any of the
I'm not sure if anybody put into the discussion the fact that they'd sort of used that technique or whatever. So, because like it did seem a lot of people had it.
Yeah, there was a mention of a secret source, but nobody shared that secret source.
Right.
There was no public notebook that implemented it, but multiple places I had read, oh, there is a way to get a better, but and if you use it, definitely your score is significantly better. And you could see that, but nobody shared what that was. But everybody who got really good scores or were on the higher echelons of the leaderboard was obviously using that technique.
Yeah.
Yeah, so I think it's kind of interesting. Like you say, sometimes the channels that people go down or the paths they take are governed by early notebooks, but that's why some of these oddball discussions help. By the way, even in Facebook, even in feedback 2 competition, there was one thing that a guy had mentioned, but he said he was too busy and so he did not have the time to do it. And I think a lot of people implemented his idea, which is, and at least many of the best notebooks in the top 10, I think, utilize this idea, which is embedding the discourse type annotations within the essay itself. And that idea was shared, and he had even, and in fact, even I had tried to do it, but, or as Jack stated it, treating the problem as one of token classification rather than of regular
but he shared it
classification.
very early on, right?
Correct. Yes, he did share it very early.
Yeah, because I guess like
but see,
I worked too slowly.
Problem with it was he did not. I mean, it was good enough for others, but at least for me, I struggled with translating it to inference because you have to basically mask a bunch of stuff, and I was getting very confused, and I gave up But if I had probably, stuck to it and not given up, I think my score might have improved even further, because basically you had to mask a bunch of stuff. And like you said, and I was still wading through that and developing the capability even based on the book, because it's almost like what you do in named entity recognition with transformers. And although we had gone past that chapter in the book we were doing, I was still struggling with internalizing the concepts from that chapter. So, but that's basically what the technique that he was proposing was. And again, the thought being like, that technique definitely was used by not all, which is self-interesting, but many of the top results competitors.
Yeah, I think his method was definitely more advanced, I would say, in terms of implementation. And nobody had shared a public notebook of that. So yeah, I mean, that's one of the main reasons I didn't go down that route.
Yeah, I tried it. I got some parts working, but I just kind of fell flat when I was trying to implement it in inference. And, I just didn't have enough time to sit down and go through it very methodically to figure out the whole implementation of it.
Right.
But I want to go back to it, just like I wanted to go back to SIFT and AWP. All right, good deal. So I think we have a bunch of stuff to do, although it might still end up saying you get the same result. So that'll be interesting. Anything else to add? If not, good luck next week. See you all next week. Thanks for joining.
Cheers. See you next week.
See you next
Bye.
week, guys. Thanks.
Bye.